Hi, my name is Haasini Alleti, and I'm a senior at Cumberland Valley High School in Pennsylvania. My research was on advancing early myocardial infarction with artificial intelligence and multimodal data. So, myocardial infarction, or basically heart attack, is a cardiovascular disease that occurs due to a lack of blood flow or oxygen to the heart. It can also occur if there are plaques blocking an artery within the heart. So to diagnose this disease, medical data such as the electrocardiogram or the ECG, lab tests such as troponin levels, medical history, and patient demographics are used. The ECG displays electrical signals of heart rhythm in the form of waves, and cardiac troponin levels involve damaged heart muscle cells leaking troponin into the blood. So basically anything above 0.1 micrograms per liter indicates myocardial infarction risk. And the problem at hand is that the disease needs to be diagnosed immediately and accurately since it is an emergency case. And this is often a challenge for healthcare professionals. Most times, the accuracy rate for doctors for early detection is averaged to only 86% according to the American Heart Association. The reason for this is that there are frequent human errors and most doctors struggle to accurately consider multiple types of medical data for personalized treatment. Personalized treatment leads to higher accuracy in general, and I thought that artificial intelligence would be the best way to try to solve this issue since it can be used to attain higher accuracies and it is able to combine more than one type of data. So currently, AI models are not permitted for such medical diagnosis, but there is still research conducted by professionals and scholars for this type of field. So while I was doing my literature review, I found that most AI models that are being created for myocardial infarction research purposes lack multimodal data and only focus on one type of input data for their models. Multimodal data means that an AI model is given multiple types of data, such as images or numbers. It considers all of the data that is inputted instead of just one. So, for example, one of the articles that I looked at, it was research conducted by Dr. Shen in his article, Acute Myocardial Infarction Detection Using Deep Learning Enabled Electrocardiograms. And his methods only included the use of the ECG. From what I learned so far in the part of research, I had three major research questions up to the point when I was doing my literature review. So one of them being, how is the use of AI superior to the methods that are being used today by doctors? And what types of data would optimize an AI model for myocardial infarction diagnosis? And the third one is, as for a multimodal model, which types of data, when combined, will increase personalized diagnosis and the accuracy for diagnosing this disease? So as for my methodology, I reviewed many credible research articles to find patterns that support my research questions. I looked at different machine learning and deep learning algorithms that are currently being used for diagnosis models that are being researched. I researched which types of data, when considered together, would optimize early detection as well as accurate personalized care. I made sure to compile a few books as well to gain knowledge for the medical aspects of my research. So mainly these books talked about how the ECGs are analyzed using their peaks and how various autonomy details contribute to this disease. And I created an annotated bibliography, and as I've researched further and further, I added or subtracted from that bibliography. Also, I found case studies of AI being used for this disease, and they are mostly test runs of AI models and how they are being used for this disease. So one particular case study that I found that was really interesting was that there was a hospital. It's actually the largest military hospital in Taiwan, and they used AI to diagnose 43,000 patients for myocardial infarction in their emergency department, and they found that the model had an accuracy of 94%. And as for my results, I found that considering troponin level data with AI models leads to higher accuracies compared to other types of clinical tests. And ECG data analysis is beneficial for emergency situations. And accuracies in this field of AI range from 82% to 99%. So considering ECG data and clinical data such as symptoms and troponin levels together would be better off since all individuals do not benefit from one type of data analysis in emergency situations. So although AI would improve diagnosis, there are still ethical concerns since such AI use involves patients' lives. So in order for an AI model to be as ethical as possible, patients should consent to the use of their medical data and be aware of safety, algorithmic, and data privacy concerns. So as you can see here, this is a scan of a person's heart, and these are their ECG readings. And you can see how that's very personal information, and people should agree to have it be used for things like training different models in the future. And also, algorithms should be highly accurate with as much data inputted as possible to increase chances of diagnosing the disease correctly. And they will also have to be adjusted continuously to new advances in the field. And as for my conclusions, a multimodal model with troponin levels and ECG data would optimize early diagnosis for MI compared to models using only one type of data. So it can act as an aid for doctors in the emergency department. Such aid can allow doctors to take proper actions earlier since the diagnosis is prompt. And in the future, these algorithms can be turned into a system where a physician inputs known medical data and gets a diagnosis within seconds and at max a few minutes. And yeah, I would like to thank Dr. Monica and Professor K, but I'll do that after my presentation.
Okay, you can stop sharing and share your thoughts about the program.
So when I first came into the program, I kind of knew that I wanted to do things in the medical field because I did research on that before. But what I really liked how Dr. Monica, when you were really passionate about what you do, you were talking to us about the chatbots you create for your students, and I found that was really inspiring, and that actually led me to be really passionate towards this project. And Professor K, you've always been really positive, and you helped me a lot, and you always checked on me and motivated me in this process. And Gift Gabarash gave me a lot. I was able to go from a young science fair kid to a young researcher, and I thank you both for that a lot.
Great. Professor Sava, question for Haasini.
I so much don't have a question for you, or more just some advice. Obviously, I think you're a wonderful student. I think you're passionate. I think I encourage you, obviously, to take this and do more with it. I want you to kind of look at two aspects that I know of that would jump on things like this, which are an NIH, which is heart, lung, and blood, which needs more research along these lines based on my interaction and working there. Also, American College of Cardiology. So those are two areas that I want you to kind of look into and reach out and see, and actually share this paper with them and see kind of what connection you can make. And if you need help with that, I will help you. But that would definitely be something that I would encourage you to do right now. So,
thank you.
Professor Kate, a question for her.
Okay, can you hear me well?
Yeah.
Okay, I know, Haasini, this is personal for you, why you chose myocardial infarction, because originally you had a different, you were going on a different direction. Okay. Do you wish to go into primary research on this, or do you wish to continue this in college, or have you decided to go into med or computer science?
I want to go into like computer engineering when I go apply for college. If I do further research, I could do further research with this. I was thinking of another project idea where I use like fractal geometry. So that's basically like different shapes. And if you use fractal geometry with like cell shapes, you could detect different types of abnormalities with that. So I would do that, and I would love to further this one because I feel like when I was researching, I didn't find much about like how impactful I did, but like I didn't find many people doing multimodal data, using multimodal data for this specific field. So I could definitely go further with this field in terms of primary research.
Excellent. Thank you, Haasini.